Question 26. Determine the amount of heat in kilojoule given off when 1.26 times 10 to the fourth power gram of NO2 are produced according to this equation. So this thermochemical equation is 2NO reacted with O2 produce 2NO2. Delta H is negative 114.6 kilojoule per mole. Actually, it's for every 2 mole of NO2 is based on this balanced equation. Right? And ask you how much heat is given off when 1.26 times 10 to the fourth power gram of NO2. 1.26 times 10 to the fourth power gram of NO2 produced. How much heat will be given off? Okay. For this thermochemical equation, so every 2 mole NO2 give off this amount of heat, right? Then this is mass. First, we need to convert mass into mole, right? So how can we convert mass into mole? So mass divided by molar mass. What is molar mass NO2? We need to use the periodic table, right? Periodic table tell you nitrogen is 14, oxygen 16. You have 2 oxygen times 2. So gram becomes more. Okay. Then every 2 more NO2 giving off this amount of heat. So every 2 more NO2 give off this amount of heat. Why is this 2 in denominator? Because here is more NO2, and here is every 2 more NO2 produce this amount of heat. So more NO2 can be cancelled, left over how much heat release. Use your calculator, you can easily gauge. This will be negative 1.57 times 10 to the fourth power kilojoule. Okay, are you okay with this? So use the thermochemical equation to calculate how much heat can be released or how much heat will be absorbed. Okay. If positive is absorbed, if negative is heat released. Then take a look. Question 35. As you calculate the amount of heat liberated in kilojoule from 366 grams of mercury when it cools from 77 degrees to 12 degrees. Okay. 35. Mercury 366 grams at 77 degree cooled to 12 degree. 77.0 is 0.77. Okay. ask you how much heat will be released. Uh, so this low chemical reaction, this physical process, just higher temperature cools to lower temperature. So this Q equal to M times S times delta T, right? M is a mass, S is a specific heat. We need to use a table. Okay, during the quiz or test, I will provide you a table. Okay, don't worry. Delta T is temperature change, final minus initial. Right? So M366 gram S from a table will be provided to you. And find mercury, the specific heat is 0.139. Unit is joule per gram per Celsius degree. Okay. Then delta T, final temperature minus initial temperature. Final 4.0, initial 77.0 Celsius degree. Okay, don't convert to Kelvin. You can use Celsius directly because here this unit is per Celsius degree. Answer is Celsius per gram, answer is gram, left over joule. Okay, this is going to be negative 3306.8 joule, or you can convert to kilojoule will be negative 3.3 kilojoule. Both three decimal places, right? 3.3 or 3.31, whatever. Fine. Yeah, more accurately, maybe 3.31, 3 significant figure, right? 3.31 kilojoule, more accurately. Are you okay with this? This is pretty straightforward. I hope everybody can understand. Okay, let's see. Then take a look at question 57. Question 57. From the standard enthalpy formation, I will provide you a table. The table lists the standard enthalpy formation for many substances. Okay. Free element 0 in their most stable state. Compound never be 0. This is Zoomer, not Zoomer camera. Yeah, this is 57. The equation is C6H2O react with, let's see, 57. C6H2O react with 9 oxygen produce 6 carbon dioxide and 6 liquid water. Ask you calculate the reactions enthalpy change. Standard enthalpy of reaction. Okay. The general formula is product total standard enthalpy formation from products minus total standard enthalpy formation from reactants. Right? So products you have 6 molar carbon dioxide, 6 times standard enthalpy formation of carbon dioxide, plus 6 more standard entropy formation of liquid water. So this is a product minus total standard entropy formation of reactants. What is the reactants? C6H2O. No number means 1, right? Plus 9 oxygen gas. This is a free element. The value is 0. So 2. Okay. So this is the formula. Product minus reactants. Right. Then you need to use a table. Find the standard entropy formation for each substance. So the table provides you the value of standard entropy formation. Carbon dioxide is negative 393.5. Liquid water, be careful, the table lists as liquid water and gas water. You must use liquid water here, list liquid water. Okay. Negative 285.8. And C6H2O, the value is negative 151.9. Oxygen gas is 0. Okay, then use calculator. You can easily get negative 3923.9 kilojoule. Okay. Are you okay with this? Okay. Generally, it's product minus reactants. Okay. Now, 63. 63 asks you from the following heat of combustion, 3 non-reaction, calculate reaction force, entropy change. Reaction 1 is CH3OH. React with oxygen gas, produce carbon dioxide and liquid water. This reaction's entropy change is negative 726.4 kilojoule. Reaction 2 is carbon. React with the oxygen, produce carbon dioxide. Reaction 2's entropy is negative 393.5. Unit is same, kilojoule per mole. Reaction 3, hydrogen gas react with oxygen gas, produce water, liquid water. This reaction's entropy change is negative 285.8. Unit is same, kilojoule per mole. Ask you use these 3 reactions entropy change, calculate the entropy formation of methanol from its element. This actually is reaction 4. Reaction 4 is synthesis. So calculate enthalpy formation of methanol. This means synthesize methanol from its element. The element should be the carbon, which is carbon graphite, hydrogen, yes, and oxygen. Oxygen, we only need one, so 1/2 of O2. Produce CH3OH. Right? Because standard enthalpy formation of this compound is synthesize this compound from its element, carbon, hydrogen, oxygen. Synthesize 1 more of this compound. Right? So ask you calculate this reaction's enthalpy change will be standard enthalpy formation of this compound, methanol. Okay. How to solve this problem? The strategy is, how can we build up this target reaction from the 3 given reactions? So simply just take a look what you need. We need 1 carbon. Then which reaction we have 1 carbon? Clearly reaction 2, right? We have 1 carbon there. So the equation 2 provide 1 carbon. Then we need 2 hydrogen. Which equation of 2 hydrogen gas? Clearly equation 3. But the equation 3 only 1 hydrogen. Then multiply by 2. The number in front of it, we can multiply. Right? 1 more becomes 2 more or becomes 3 more. Right? So we need 2 times equation 3. Then we have 2 hydrogen. 1 carbon from reaction 2. Hydrogen from equation 3, you need to multiply by 2. Then we need oxygen, right? Oxygen, every equation has oxygen. Okay. So this oxygen actually already there from equation 2, equation 3 books provide oxygen. So just set aside, don't worry about it. Then we need CH3OH, methanol, as a product. Take a look which equation has methanol, equation 1. But the equation 1 product serves as a reactant in the left side. Just minus equation 1, move to the right side is the product, right? Minus equation 1 will be served as product. So from these 3 equations, equation 2 plus 2 times equation 3 minus equation 1, we clearly have carbon, hydrogen, and methanol. This is not sure because this equation, or this equation all provide oxygen. Right? So anyway, oxygen already there. You're just not sure if this is 1/2. The amount may not exactly. This is the question. The other is carbon dioxide and water for these 3 equations. Right? So carbon dioxide, water, plus is this oxygen gas exactly the same as we want? You're not sure, but we are sure it's carbon, hydrogen, methanol, all correct. Right? So you may have a question if this actually give equation 4. If you want confirm, you can work on those scratch paper to confirm this given equation 4. And show you here. Just use this formula. Work in each side. Okay, work on left side first. Equation 2, left side is a carbon plus oxygen, right? And 2 times equation 3 2 times equation 3 will be 2 hydrogen gas plus 1 times 2 is 1, right? 1 oxygen plus 2 hydrogen and 1 oxygen. Then minus equation 1, so minus this, minus 3 half oxygen. We use this, finish the left side. Now we use this formula again on the right side. Okay, the right side equation 2, CO2. The equation 3 times 2, water. Then minus equation 1, minus CO2 minus 2 water. Right, we finish this formula on the right side. Now just simplify this to see if this gives you the target reaction. Equation 4. You find O2, 3 half O2, and O2 is 2 O2 minus 3 half, or 1 half left, right? So left side carbon on the 1, hydrogen 2, nothing can combine. Oxygen 1 half of oxygen minus CO3OH. Right side, all gone, right? Right side and nothing left. And chemical equation normally no negative. Then we move this to the right side, be positive, right? Is this the equation you want? Yes, this is the equation you want. Equation you want is this. Yes. This means we confirmed this formula will give you equation 4. You confirmed in the smart paper. Okay. During the quiz, you don't have to show me this, but you must show this formula before you go to next step. Okay. Since we confirmed from this formula, we can get equation 4, then use this formula. Delta H2, this is not delta, equation 2, you just use delta H2, right? Equation 3, delta H3. Equation 1, delta H1. And equation 4, delta H4, right? So delta H4 is the one you want to figure out, right? So delta H4 is the standard enthalpy formation of methanol equal to delta H2. The value is negative 393.5 plus 2 times delta H3, negative 2 times negative 285.8 minus delta H1 is negative 726.4. Be careful, this is minus negative. Delta H1 itself is a negative value. Then use a calculator. You can get this number is negative 238.7 units kilojoule. Okay, are you okay for this?